Okay, so problem 8.11, find coefficients a and b so that, and then we have these two equivalences, right? So first, let's start with the first one. X minus a plus b times the cosine of x sine of x is small o of x to the fourth. When x gets very small, right? So let's see. Here what we have is we want things to be small o of x to the fourth. So what we are going to do is approximate the cosine and the sine by the Taylor polynomial up to so that the resulting expression is a polynomial plus terms in small o of x to the fourth, and then we can eliminate these remaining terms, right? So then we have the sine is going to be x minus x cubed over 6, right? Plus small o of x to the fourth, right? So now, so that with that we can just get the cosine in 1 minus x squared over 2, and if you can see, it doesn't really pay to include the term in x to the fourth here, because it's going to be multiplied by an x here in the sign. So everything else here is small o of x to the fourth, but when it's multiplied by the x in the side, it's this is small o of x cubed, small o of x cubed, but when it's multiplied by x, it becomes x to the fourth, right? So then here this is x minus, and then you have a plus b minus b halves of x squared plus small o of x cubed, because b times x cubed is this, times x minus x cubed over 6 plus the small o of x to the fourth is equal to small o of x to the fourth. All of this when x goes to 0. Now if you multiply this is x minus, and then this is a times x minus a divided by 6x cubed plus so this is a plus b. The terms in a plus bx minus a plus b over 6x cubed, and then we have minus b over 2x cubed plus and this is small o of x fourth, and so everything else is small o of x to the fourth, right? Small o of x to the fourth. Now if we want all of this to be small o of x to the fourth, that means that this part here has to be equal to 0 for every x, right? So that implies that then we have the terms, the coefficient of the x term has to be equal to 0. So in other words, 1 minus a minus b has to be equal to 0, and the coefficients in the x cube has to be equal to 0, right? So we have a plus b over 6 plus b over 2 have to be equal to 0, right? So now we have this is equal to, let me write this again, this is a plus b equals 1, yes, and then this is, if we take everything in the same fraction, this is 6, this is 3, 3/6, right? So this is a plus 4b equals 0, right? So let me write it here. A plus 4b equals 0. So we have a system of linear equations with two variables. So this clearly has a solution. So let me just subtract these two identities. So we have minus 3b equals 1. So this implies that b is minus 1/3. And this implies that a is 4/3, because this is 1 plus 1/3, right? So this is a and this is b, right? You see? Okay, let's do the second one. Now here we have the cotangent of x minus 1 plus a squared divided by x plus b x cubed is small o of x to the fourth when x goes to 0, right? So here as you can see, there's a common factor here in the denominator. This is x1 plus bx squared. So we can actually multiply everything by x, right? So we have x times the cotangent of x minus 1 plus ax squared divided by 1 plus bx squared is small o of, and then you multiply this by x. This is small o of x to the 5, right, when x goes to 0, right? And this is valid because if this is approximate when x goes to 0, that means that x is never going to be exactly equal to 0, right? Okay, so then we have this, and now we can, what we can do is we can wait a minute. So yeah, what we want is that this cotangent, let's see. So what we want is to, wait a minute. Well, first of all, yes, sorry. Let's expand it, the cotangent, right? I don't expect you to remember the expansion for the cotangent. So what we can do is we say, well, this is the cosine divided by the sine, and we know the expansion for the sine, we know the expansion for the cosine. So this is x times the cosine. Let's expand the sine. So this is 1, sorry, it's x minus x cubed over 6, and then plus x to the 5 divided by 120, right? Plus small o of x to the 5, which is what we want, right? But now we have an x here, so we can divide everything by x. So this is the cosine is divided by 1 minus x squared divided by 6 plus x to the 4th divided by 120 plus small o of x to the 4th. Okay. But now here we have the cosine times 1 divided by 1 minus, and we have x squared over 6 minus x to the 4th divided by 120 plus small o of x to the 4th. And this, the expansion of this is the geometric series, right? So this is the sum, well, let me write it, just the first terms, right? So this is 1 plus, and then we have x squared divided by 6 minus x to the 4th divided by 120, and then we have plus this thing squared, right? And this thing squared is going to be this squared, so this is x to the 4th over 36, and plus this x squared, which is all of that is small o of x to the 4th. Okay. And the interesting thing is that the cosine, let's see, sorry, this is, yeah, the next terms are x to the 5, sorry. Yeah, I'm being stupid here. So the next terms in the cosine, the sine expression are small of x to the 6. So when you divide by x, you get small of x to the 5. Okay, which is what we want. Now, if you compute this difference, you get to 360. This is 10 minus 3. You get 7 x to the 4, right? And now we can multiply by the cosine, which is 1 minus x squared over 2 plus x to the 4th over 24 plus a small o of x to the 5, actually, right? Because the next term is x to the 6, right? So now we can compute this thing, and if you do it, you will get 1 minus x squared over 3, because you get x squared over 2 minus x squared over 2 plus x squared over 6. And then you can compute all the terms with x to the 4th, and you get minus x to the 4th divided by 45, and everything else is small o of x to the 5, right? So we have this term here, and let me write it here. So this is x times the cotangent, if you remember. This is 1 minus x squared over 3 minus x to the 4th times 45, and then we have this here, right? So let me here. How do we expand this? Well, again, we can use the same thing. We have here, this is 1 plus ax squared times 1 over 1 plus bx squared. Or in other words, this is 1 minus bx squared. And we know how to express this thing, because this is 1 plus ax squared, and this is 1 minus bx squared, right, plus b squared x to the fourth, and then the rest thing is small o of x to the 5, right, because the next term in this geometric sum is b cubed x to the 6th, right? So now we can expand this. This is 1 plus, and then we have a minus b x squared, and if you compute the terms in x to the 4th, you have bx squared, and you have a times minus b, so you have b, and then b minus a times x to the 4th, and then everything else is small o of x to the 5, right, because you have x squared times x to the 4th, x and x to the 4th. So yeah, that's it, right? So these are these terms. So you have 1 minus 1 minus or plus b minus a x squared, right? And then we have minus this, so plus b times a minus b x to the 4th, and then everything else is plus small o of x to the 5 equals small o of x to the 5, right? So now if we want this thing to be exactly small o of x to the 5, this polynomial here has to be identically equivalent to 0. So that means that all of the coefficients have to be 0. Well, here we have minus 1 and 1 go away, and then you have the terms in x squared are minus 1/3 plus b minus a have to be 0, right? And then we have minus 1 over 45 plus ab minus b squared have to be equal to 0, right? So now again we have a system of two equations. These are not linear, but we can compute them easily. For instance, so we have let's see, so we have a is equal b minus 1/3, right? And so this is here we have b squared minus ab plus 1 over 45 equals 0, and this is equal to b squared minus, and then we have a times b minus b squared, right, plus 1/3 of b, yes, plus 1 over 45 equals 0. This goes away, and solving this, we get that b is minus 1 over 45 times 3, so this is minus 1 over 15, right? And then here we have b is minus 1 over 15 minus 1/3, or in other words, this is 5 divided by 15. This is minus 6 over 15. Okay, so these are a and b. Okay, but interestingly, if we go back to the beginning, what we wanted was, if you see an expression of the cotangent as a rational function like this, 1 plus ax squared divided by x plus bx cubed plus small o x to the 4th. Okay, so this is an expression of the cotangent that's very good, rational expansion of the cotangent that's very good at 0 with only these terms, right? And this is using the terms that we have, is we can multiply by 15. This is 15 minus 6x squared divided by x, 15x, sorry, minus x cubed. This is the approximation that we want for the cotangent.